EV Expert, e-learning, diagnosis. PD, proximity detection, and CP, control pilot signal. Overview. CP and PD are signals for EV charging process. In case of slow or normal AC charger, it charges the high voltage battery through the OBC. In case of fast DC charger, it directly supplies 400 volt DC to charge the high voltage battery. When the charger is connected, the OBC checks its connection status with an electric signal. This is the proximity detection PD signal. CP, control pilot, is a communication signal related to information of charging process between charger and EV, such as charging type and battery SOC. Therefore, CP and PD signals are very critical in the EV charging process. Now, let's take a look at CP and PD signals in detail. PD, proximity detection, and CP, control pilot signal. PD and CP system configuration. How does Kona EV charging work? Let's take a look at normal AC charging first. In normal AC charging, the charger exchanges information with the OBC through PWM communication of the CP line. With this information, the OBC performs charging process using CAN communication with BMU. Let's take a look at the normal AC charging process in more detail. When the charger is disconnected, the charger outputs 12 volt voltage through the CP line, and the OBC outputs 0.7 volts voltage. When charger is connected, the 12 volt voltage from the charger's CP line drops down into 9 volts by the internal circuit resistance of the OBC. By detecting this voltage drop, charger and EV recognize the connection. For permission to charge, the charger transmits CP signal to OBC in PWM waveform, and OBC receives this signal and activates IG3 relay number 1 to power the charging-related controllers. The OBC converts 9-volt duty waveform into 6-volt duty waveform to request charging power from the charger. The charger supplies AC power to the OBC. The OBC boost converts the supplied AC power into 400-volt DC power to charge the high-volt battery. The OBC requests the BMU to set PRA main relay on. The BMU sets PRA main relay on and feeds back to OBC. The OBC supplies 400-volt DC power and starts charging. Now let's take a look at fast DC charging. Fast DC charging charges the high voltage battery directly without converting or boosting. And there is a controller that takes an important role during fast DC charging process. It is a CCM, Charging Control Module. The CCM performs as a communication gateway between the charger and the BMU. It translates and connects DC charger using PLC communication and BMU using CAN communication. PD, proximity detection, and CP, control pilot signal. Signal analysis and circuit inspection. Let's check the CP and PD signal values when connecting the ICCB to the Kona EV. Select Data Analysis. Select OBC from Data Analysis. From current data, select PD voltage and PD status. Then select CP voltage and CP duty. And to monitor inlet lock status at the same time, select Inlet Lock Function Status. Inlet Lock Actuator Status. Inlet Lock Actuator Fail Status. And Inlet Auto Lock Mode. Go to Graph Mode. The charger is not connected yet, so the PD voltage is 4.45 volts, CP voltage is 0.55 volts, and CP duty is 0%. Inlet Lock Function Status shows Unlock. Inlet Lock Actuator Status shows Normal. Now, let's connect the charger. The PD voltage changes to 1.51 volts. The CP voltage rises up from 0.55 volts to 9 volts, but with PWM communication, it drops down to 6 volts. At this time, CP duty is 20%. It means 12 amperes charging current. Inlet Lock Function Status shows Lock. Inlet Lock Actuator Status shows Normal. If you press the unlock lever, the PD voltage rises to 2.76 volts. If you release the unlock lever, it changes back to 1.5 volts. Let's unlock the vehicle's door and disconnect the charger. The PD voltage returns to 4.45 volts, and the CP voltage drops to 0.5 volts. Inlet lock is unlocked, and the system is normal. As we just confirmed, CP duty value changes according to the current supplied by the charger. In case of common 3 kilowatt ICCBs, 12 ampere charging current shows 20%, 10 amperes shows 16.6%, and 8 amperes shows 13.3%. And for 7 kilowatt normal AC chargers, 32 amperes charging current shows 53%. If fast DC charger is connected, the duty output is fixed at 5%. Therefore, CP duty can show information of charger connection status, charging type, and charging start-end information. Now let's check the PD signal in Combo Type 2. Compared to the CP and PD signal in Combo Type 1, signal of Combo Type 2 differs only in PD signal. Before the charger is connected, the PD voltage is 4.45 volts. Just after the charger is engaged, the PD voltage changes to 3.1 volts. The CCS2 charging connector has 4 kinds of resistors, depending on the maximum current capacity of the cable. The ICCB connected now has a capacity of 20 amperes and a resistance of 680 ohms. Therefore, PD value is confirmed as 3.1 volts, which is higher than 1.5 volts of CCS1. PD, proximity detection, and CP, control pilot signal. CP, PD signal line inspection. For PD signal line inspection of ICCB, the resistance between PD and ground terminal must be measured after disconnecting the minus terminal of 12-volt battery. The default resistance for Combo Type 1 is 150 ohms. The measured value with the lock lever pressed should be 480 ohms. Combo Type 2 has no lock lever, but has 4 kinds of resistances according to the charging cable maximum capacity. If 680 ohms is measured in the ICCB, it is normal. CP line inspection for EV inlet side is same for Combo Types 1 and 2. After disconnecting OBC signal connector, measure CP line end resistance of the inlet side and OBC signal connector side. is less than 1 ohm, it is normal. In the same manner, short circuit test should be performed with minus terminal of 12-volt battery and an OBC connector disconnected. If the measured resistance between the CP signal line and the vehicle ground is infinity, it is normal.